Everyone, I am Meenakshi from Rohini College of Engineering and Technology. Today we are going to see the topic Sdes. Sdes is nothing but Simplified Data Encryption Standard. So this Sdes encryption algorithm takes a plain text as the input. The plain text block size is 8 bits, and for encryption we use the key of size 10 bits, and after the encryption it again produces 8-bit ciphertext. So this is also an example for symmetric encryption, that is the same key is used for both the encryption and the decryption. And for the decryption, again the 8-bit ciphertext block, it is given as the input and the same 10-bit key is used, and after decryption it produces the 8-bit block of plain text. So this is the overall structure of simplified DES. So we have the input 8-bit plain text. So initially it is permuted, that is the letters are rearranged using the initial permutation. Then it is given for complex function. After the function it is swapped, the contents are exchanged. Again we go with one more complex function. Then we go with inverse initial permutation and we get the 8-bit ciphertext. And for each function we have used two different keys, K1 and K2, and these two different keys are generated from a 10-bit key. For decryption the same process is applied. So initially the initial permutation is done on 8-bit ciphertext, then it is applied to a complex function, then the swapping is done, again one complex function, and finally the inverse initial permutation, and we get the 8-bit plain text block. So how the keys are generated? So initially we have a 10-bit key, so it is applied to a permutation, then we go with the shifting operation, then again the permutation, we get the first key. Okay, to get the second key, after applying the first shift operation we go with another one shift operation and we go with the second permutation, thus we obtain the second key. So in detail we have seen in the second diagram. This is a key generation diagram. So as I told, we have a 10-bit key. So first it goes with the permutation, then the keys are splitted and they are left circular shifted also. After the left circular shift it is once again permuted and it is contradicted, that is the bits are reduced to 8 bits. Okay, and these 8 bits are given to the complex function, that is K1. In order to get the second key, before applying the permutation, okay, the shift value is given to the second shifting operation and we get the 10 bits. Then we go with the contradiction, the permutation, that is the bits are reduced and we get the second key. So what is happening in Sdes encryption? So Sdes encryption algorithm involves 5 functions. One is the initial permutation, the second one is the complex function fk. So it operates on the plain text block and the key, and which comprises permutation and substitution operations. Then the single permutation function that switches the two half of the data, that is it exchanges the left half with the right half and the right half with the left half. Then again the function is applied, the same function fk is applied but with the different key, and finally we have the inverse initial permutation and we get the 8-bit ciphertext block. So how the function is depicted? So this is the function block diagram. Okay, so we will see in detail in the next diagram. So this is the function. So initially we have the initial permutation, then the expand permutation is done, we get the 8 bits and they are shifted. After the shifting we go with the permutation, Okay, after the permutation, it is XORed with the initial permutation output, and after that the swapping is done. So substitution and transposition are used in function. Okay, they are the components of the function fk. So EP is nothing but expand and permute, that is the bits are expanded as well as they are rearranged. For example, if the input is 1 2 3 4, the contents are rearranged. Similarly, the bits are expanded. We are adding extra bits in order to make them as length 8. Okay. Then initial permutation, that is the plain text letters are rearranged. Then inverse of initial permutation, then left shift 1 position, left shift 2 position. Okay. So with this we are concluding symbol des operation. Thank you all.